Hello, in the last video we looked at the theory of transformations and we looked at specifically amplitude and period as they relate to sine and cosine functions. In this video we're going to look at a bunch of examples about how to apply that knowledge to different problems. So let's start off with a nice simple problem here. Example 1 here on slide 9 is we've got y equals 3 sine 2x and we're asked to identify the amplitude and period. Let's just do it. So the amplitude is simply 3. It's the value in front of the function there. The period is equal to 2 pi. This requires a little bit of calculation. Is 2 pi divided by 2, which is equal to pi. So it will repeat itself every length of pi. Next example, y equals 5 cos half of x. Amplitude, again, really easy. The amplitude is 5. The period, however, does require a couple of steps here. We start off the same way, 2 pi over 1 half. And if your fraction knowledge is weak, this might be a bit challenging for you. So I'll take a couple of steps to do it, but you could do it in one step, no problems. That's 2 pi divided by 1 half. And our fraction knowledge hopefully will say that if I'm dividing by a fraction, it's the same as multiplying by the flip, which is 2 over 1, which is just 2. And so the period is 4 pi, and again, that makes sense. I'm slowing down the input, so I'm stretching out the period. This one here on slide 11 makes it different because of the negative there. So the amplitude is not negative 2. The amplitude is just 2. Let me explain a little bit more. If we look at Desmos and I change n back to 1, so looking at the base graph here, like so, what do we know about transformations when we make the a value negative? Do you remember? Effectively, what we're doing when we make the a value negative is that we're changing the output's sign, sign. So where it was positive, it would be negative, and where it's negative, it would be positive. So effectively, when I make this negative 2, all I'm doing is I'm creating exactly the same shape, but upside down. So instead of being positive like that, it is negative like that. Instead of going then down here, it's now going up. So it's been flipped around the x-axis. And that's what we say, isn't it? It's reflected about the x-axis. That's what that transformation does. So in terms of our theory, the amplitude is still 2 because the height from the x-axis to the top, or the depth, still remains 2 units from the x-axis or from the center of the graph. So we say that the amplitude is 2, not negative 2. And that means I really should go back to those notes there and I should change it to say the absolute value. And absolute value simply says, look at the size of the number, ignore the sign of the number. So if a is negative, then the result of the absolute value of a is positive. What about the period? The period, well, there's no number here, which means it must be the basic period of 2 pi. You can also think of it as 2 pi over n equals 1, so it's 2 pi over 1, if that floats your boat better. The amplitude here is 3 cos pi on pi x, is simply going to be 3. There's no tricks there. The period is a little bit interesting again. We've got a pi there, but don't let that fool you. Even if there's a pi there, we just do the same effect again. We say the period is equal to 2 pi divided by whatever it says in front of the x, which in this case is pi. The pi's, of course, will cancel out, which means the period is equal to, just 2. Just a single value of 2. No pi's involved. No pi's were harmed in the making of this function. It is simply from 0 to 2 would give me 1 cycle. This next example here is, let's just say we're given a function, we're told to sketch it. How do we use all the information we've got in order to sketch it? Okay, the first things we do is we're going to just identify, like we did those last few problems, what the amplitude and the period is. So the amplitude is 2, and the period is equal to 2 pi on 2, which is equal to pi. Here we go with the graphing. Graphing functions, sine and cosine functions, is a bit of an art form. I'm not the best grapher in the world, so bear with me. First things first, we're going to put our amplitudes in. So that means we're going to go from 2 and to -2. And I'm trying to keep them as simple as I can. Some people recommend doing this, putting in little dotted lines to show this is where the graph has to hit. I don't necessarily do it myself, but it might be useful right now just to show you what happens. The next thing to do is to put in the cut points for the cycle. So this is, to me, the easiest way of doing it. So I know I need to go from 0 to 2 pi, but let's just start off with the first cycle, which is pi. What we do is we keep on halving, no, we do 2 halves. So if I halve pi, I get pi on 2. This will all make sense once I've finished. And then, that's a little bit off, I'll do a little bit further down, pi on 2. And then I halve each of these again. Half of pi on 2 is pi on 4, and half of, and between pi on 2 and pi, well, that's 2 pi on 4 and 4 pi on 4, so it's 3 pi on 4. So I've got these 4 dots. Next, I work out where the maximum and minimum are. So I'm going to do this in a different color again. Might do it in orange just so it really stands out. But I know that it's a sine graph, so it's going to start here. Then it's going to go up to a maximum point because it's not reflected, so it's going to go up, which means at pi on 4, it's going to go up to here. And then on pi on 2, it's going to go here. I'll make the dots really big so you can see them. And then at 3 pi on 4, it's going to go down here. And then at pi, it's going to be back to the start again. That's one cycle. So these orange dots allow me to really see how I'm going to do the graphing. Next, I'm just going to do my arcs a bit at a time. And again, I'm on my iPad, so it's even worse, but here we go. I'm going to do one little arc here, and then I'm going to do another arc here, and then I'm going to do a third arc here, and then a fourth arc here. And then that's one cycle done. I have to do 2 cycles, so I'm going to repeat that again. So I'm going to go to 2 pi now. So between pi and 2 pi, what's going to be the middle of that? 3 pi on 2, 1.5 pi. Okay, so I've got to put the values now between pi and 3 pi on 2 and the middle dot between 3 pi on 2 and 2 pi. So, well, I can see that I'm going up in pi on 4s, aren't I? So I've got 3 pi on 4, 4 pi on 4, 5 pi on 4. So that's going to be my next division here. 6 pi on 4, 7 pi on 4 become my dots here. And now I'm going to draw my dots in. And again, it's just like it starts here, and then the next division along will be my maximum. The next division along will be my 0. The next division along will be my minimum. And the next division along will be my maximum again. And then I can draw my arcs up. So that'll make it like this, and then like this. Oh, that's a bit poorly drawn. Then like this, and then like this. Please draw better than me. I've made it a little bit too wobbly here. But you get a sense of this sinusoidal pattern going along here. My maximum, my minimum, and I'm basically done there. Make sure that says -2 because I can't quite see that negative. Okay, that's that graph done. Next problem, last problem for this video. What happens if we've got the sketch and we need to look at that dodgy sketch? That's one of mine as well. What happens if we've got the sketch and we need to work out the function? Well, for this year, we only have to worry about the function being in the form of y equals a sine nx. In your information sheet, by the way, that a is lowercase. So what do? Well, first of all, we identify the amplitude. So a is equal to, let me see, we've got it going from +3 to -3. So the height or depth is just 3. So the amplitude is equal to 3. And so therefore A equals what? It's not 3 because I can see that the graph is starting from 0, but instead of going up like the normal graph does, it's going down. So it is upside down. It is reflected, which means that A is equal to -3. Hope that makes sense, that A would equal -3. By the way, how did I know to start with sine instead of cosine? Well, it's got to do with the starting point. Now, next year, you might find, if you do maths methods next year, you might find there's a little bit more to the story than this. But effectively, because it's starting at 0, I'm going to start with sine. If it started up here, or down here, I'd start with cosine. Okay, we need to work out what n is. N is the period. So when I look at my graph, I can see that it has one period for 24 units. That could be hours, for example. Maybe this is a tidal chart. So I start off by saying the period is equal to 2 pi on n, which is equal to 24. And now I solve for n. So I'm going to multiply both sides by n, and I'll get 2 pi, I shouldn't have that equal sign there, 2 pi is equal to 24n, and then I'm going to divide both sides by 24 to leave myself with n, but I'll put the n on the left-hand side. So I'm going to have 2 pi on 24, or pi on 12. So that means that the function is y is equal to negative 3 sine of pi on 12 x, and we're done. You may see it written like this. And if you don't understand why it looks like this, you better ask. These are equivalent. They are exactly the same expression. That'll do for today. Go do some problems out of your textbook. Look at the learning schedule to see what you need to do.